So what do we do if a straight line doesn't fit our data well? Well, if the curve gets steeper, we usually look at exponential growth. So let's look at an example. So here we have annual sales revenue of Cisco. Year one is 1990. You might wonder why I didn't put 1990 there and I put a one. We'll answer that question shortly. And if we graph this revenue, with this being on the y-axis and the year being on the x-axis, we'll see a straight line is really not reasonable. So what should we do? Well, the answer will be exponential growth, which we'll describe in a moment. So we do insert, scatter plot like we did in our last video. Okay, now if you think that should be a straight line, you probably need glasses or you don't know what a straight line is. That curve is getting steeper. And that's a very common pattern for revenue growth for a new high-tech company. So if a curve gets steeper, we want to fit exponential growth. What does that mean? It means we're predicting y equals a constant a times the number e, 2.7182, raised to a power b times x, where x would be the year number, with the first row being year one. Why we don't use 1990 is you took e, which is around 3, to the 1990, it would blow up the computer. So you have to start with year one. So the question is, what values of a and b would best fit this data, and the trend curve can tell us. And then the property of exponential growth, which is important to us, is whenever x goes up by 1, y always increases by the same percentage. And that's what's called the CAGR, or the compound annual growth rate. In other words, whenever x goes up by 1, you'll see in a moment, our prediction for y revenue goes up by the same percentage. And that's our best estimate of the growth rate during the time period. Although in the future, usually the compound annual growth rate for a high-tech company will eventually drop. But let's try and fit the exponential growth equation here. So remember, we do right click, we select the points, we do right click, add trend line, and then we're going to do exponential, and we can do equation on chart. The R squared is a bit misleading in this situation, so I'm not going to even show it. So now if I make that a little bit bigger, as I select this, I do Control 1, and I can say font size, let's say 15. Okay. You can see that does a pretty good job of fitting the curve, except for the last point. The last point falls far short of the prediction. And that often happens with exponential growth. In this case, year 10 was 1999, and then the tech recession started right after. And you could see the exponential growth for Cisco sort of stopped and basically, or decreased, and it never really came back again, which is common with high-tech companies. Show me a company that grew for 30% or more for 30 straight years. I'll show you a company that probably never existed. I'll give anybody $50 if they can email me a company that meets that criteria. Now, what would we make our prediction for each year be? It would be 58.553 times the EXP to the 0.5694 times the year number. Now, I've meant that we don't want an X there. 58.553, I hit the wrong key there. And then basically that's our prediction. Just copy that down. You see in year 10, we predicted 17 billion. This is in millions, these sales. And Cisco only came in at 12 billion. That would indicate they just aren't going to ever catch up to the compound annual growth rate. So what was their compound annual growth rate? Well, you take the prediction for one year divided by the prediction for the previous year. So the prediction for the second year was this, divided by the first year, and you'll see every year that ratio is the same. That's what I mean when x goes up by 1, y always increases by the same percentage. So 76%, 77% was the CAGR, 76.7. That meant during this wild period of internet growth, Cisco's annual revenues grew at about 77% a year. And you just can't keep that up. I mean, there's no way. If you would extrapolate this prediction to year 16, which was 2005, and just copy that formula, you would have a prediction that Cisco would be a $530 billion company. And to be honest, that would have made them the biggest company in the world in 2005. And I think actually that prediction was made in 1999. Cisco at one point in 1999 had the biggest market cap in the world. It used to cycle between Microsoft, GE, and Cisco in 1999. And Cisco is a great company and has done well, but certainly has not grown at that rate. Now in the next video, we'll show you another example of, we show you another example of fitting a nonlinear curve the power curve, which is used to model data that gets flatter, either flatter increasing or flatter decreasing.